We will be going through the Newton Raphson method for finding the root of equation f of x equal to 0. So for this particular method, we need an initial guess for the root of f of x equal to 0. So let the initial guess be x of I. So according to NR method, x of I plus 1 is given by xi minus f of xi divided by f dash of xi. F dash of xi is defined as the differentiation of f of x with respect to x. We need to perform the iterations until f of xi plus 1 is approximately equal to 0, or the relative error percent E of A is within a desired tolerance limit. E of A is defined as the ratio of current approximation minus the previous approximation divided by the current approximation multiplied by 100. So for example, we'll take f of x as 2x cube minus 2.5x minus 5 equal to 0. So we need to find the root of f of x equal to 0 using the NR method. The first step is to calculate the differentiation of f of x with respect to x, that is f dash of x, which comes out to be 6x square minus 2.5. We consider the initial guess to be equal to 2. So our initial guess is 2. So our f of xi will be calculated by substituting x as 2. So we get value of f of xi as 6. Similarly, the value of f dash of xi we get as 21.5. So according to the NR method, x of I plus 1 is equal to xi minus f of xi divided by f of f dash of xi. For I equal to 0, x1 will be equal to x0 minus f of x0 divided by f dash of x0. We know that x0 is 2, f of x0 is 6, and f dash of x0 is 21.5. So therefore x1 will be equal to 2 minus 6 divided by 21.5, which comes also to be 1.72093. And the value of f of x1 is equal to 0.89108. We will continue to perform iterations until f of xi plus 1 is 0 and the relative error percent E of A is greater than 10 to the power minus 4. So we'll make a simple table to perform the iteration. So we have xi plus 1, f of xi plus 1, and E of A. So for the first iteration, the initial condition xi equal to 2 and the relative error. There is no relative error as this is the first iteration. So for the second iteration, our initial guess will be the value of previous x of I plus 1. Using the NR method, we get x of I plus 1 for this particular iteration as 1.66257. F of xi is 0.0347241, and the value of relative percent comes out to be 3.51. So we'll continue to perform the iterations. We get 2.409 to 10 to the power 4. And we get the relative error as 0. So as we can observe that the value of f of xi is approximately equal to 0, and E of A, which is the relative error, is less than 10 to the power 4. So the root of f of x equal to 2x cube minus 2.5x minus 5 equal to 0 is x equal to 1.66010.